Okay, here's an example that's slightly more interesting. Also, hopefully you can hear me talking properly now, as I've just realised the last two videos I did, my microphone wasn't actually plugged in properly. So hopefully I'm making a little bit more sense and you can now fully appreciate the rich baritone nature of my voice. Anyway, moving on. Right, you've been given a problem like this. 1 plus 3 over 2x minus 1 plus x plus 1 over 6x squared minus 3x. Now at first glance it might look like it's a lot more complicated than the examples we've looked at already. But it isn't really. What we're going to do is, just as we've done in every other example, we're going to take each individual term and get it over a common denominator. So we're going to have to take this number 1 and turn it into something over an algebraic common denominator, and we're going to have to turn this into something with a common denominator to this and this. So first thing we're going to do is, let's see if we can factorise what's on the bottom of this fraction here to see if it gives us a clue as to what the other two denominators will end up having to look like. And hopefully you'll be able to spot that there's a common factor of 3x in both of these terms. So we can rewrite 6x squared minus 3x as 3x and then in brackets 2x minus 1. Now that's quite handy because what's the denominator of this fraction? 2x minus 1. So what do we need to multiply this fraction by on the top and on the bottom so it has a common denominator? Well, it's already got a 2x minus 1 on the bottom, so I need to multiply it by 3x. And whatever I do to the bottom, I need to do to the top of this fraction, so I'm going to end up with 3 times 3x on the top. Now this one is slightly different to what we've looked at so far, but it's the same principles. The number 1, remember, can be written as something divided by something divided by itself, in essence. So if we're going to have this, and we're going to turn it into a fraction that has the common denominator of 3x over 2x minus 1, then on the top we're going to have 3x brackets 2x minus 1. So we've now managed to take each of these terms and rewrite them all as a common denominator. And so now all we need to do, as it were, is to get this all into one fraction and then tidy things up. So first of all, let's expand the brackets here. I'm going to have on the top, I'm going to leave it actually for now. Let's think. Do I want to expand these brackets? No, I think for now I'm going to leave it as 3x, 2x minus 1 plus 9x plus x plus 1 all over the same common denominator, 3x, 2x minus 1. Can we tidy it up any further? Let's have a look. Yeah, that will become 10x. Aha, this is beginning to look like a quadratic on the top, isn't it? If you have a look, we're going to end up with 6x squared minus 3x plus some x's. So let's just expand the brackets and tidy this out. 6x squared we're going to have. We're also going to have minus 3x, but then we're going to have plus 9x plus x. That's plus 10x. Take the 3x. That's going to be plus 7x plus 1 on the top. And on the bottom, we are going to have 3x, 2x minus 1. And I'm just wondering now whether we can factorise the expression on the top. And I think we can. I think I'm going to end up with 6x plus 1 and x plus 1, I think. Let's just have a check. 6x squared plus 6x plus another x plus 1. Yep, that works out there. And sometimes what you get, but we haven't in this case, sometimes what you get is a common factor top and bottom, so you can cancel things out. In this particular case we haven't, so we're going to leave that expression as it is. So we've managed to turn 1 plus 3 over 2x minus 1 plus x plus 1 over 6x squared minus 3x into something that looks a little bit simpler, like so. Now let's take this next example. 6 over x plus 2, take away 3 over x squared plus 2x. Just as before, the first thing we've got to do is we're going to see if we can factorise any of these denominators to see if it gives us a bit of a clue as to what we're going to end up turning our common denominator into. So in this particular case, this has got a common factor of x. And that's quite handy, because we've got a denominator over here which is x plus 2. So what do I need to multiply this fraction by to have a common denominator of x times x plus 2? I need to times top and bottom by x. Okay, so notice I haven't actually combined these fractions yet. I'm just making the two fractions have a common denominator all the way through. Now we can combine these fractions because they've got a common denominator. And be left with 6x minus 3 over x plus 2. And then the question is, can I factorise this at all? Yeah, common factor of 3, 2x minus 1 all over x brackets x plus 2. There's no common factor here for me to cancel down by, so at this point I would stop. I've simplified it as much as I can at this stage. But this is an exam style question. This could be sort of part A of a question might be simplify this fraction, and part B might be now go and solve an equation that's linked to this. Let me show you what I mean. Imagine you are now told, hence solve this equals 1. Can you see we've got the same thing going on here, but they've now said say this equals 1. What are you going to do? Well, normally when they say hence, you're meant to go back and see what you've just done. So in essence, what they're asking you to do to solve this equation is to rewrite this as the answer you just came up with. And we're going to set it equal to 1. And now what we're going to do is solve the equation in the way we would normally. So I've got the unknown, the thing I'm trying to find on the bottom of my fraction. So I'm going to multiply both sides through by x plus 1, which will leave me with 3 brackets 2x minus 1 on the left hand side, and on the right hand side I'm going to have 1 times that. And now we're going to expand the brackets. Aha! We've got a quadratic going on here, so let's take everything over onto one side. So we've got plus 2x, but take 6x minus 4x plus 3. It looks like the kind of quadratic that we can factorise by looking at it. It's got minus 4x but a plus 3 at the end. So because we've multiplied and got plus 3, both signs must be negative. What multiplies to give me 3, 3 and 1. So either x equals 3 or x equals 1. Ta-da!